will be Tomasz Cizmuzia. He will hold the presentations about searching. I would like further to mention my other three colleagues who helped us enormously in preparing this presentation. Beside the presentation, I will show you some code snippets which were also presented by me and by my colleagues. You can find these code snippets on our website as well. Here, I type it in the chat box, so you can open it. Okay. Janci, please send it to the entire audience. Okay. Yes. But I will show these code examples in my Eclipse window, but afterwards you can find just the same files on the internet here on this JChem code example site. Okay, let's get, and I will also show some files here in my file browser, and sometimes I will open an SQL Workbench program to show what we achieved in the database during our manipulating programs. Good. Okay, let's jump into the presentation. So first, some words about the contents. The story begins always with substructures, chemical structures, and usually they have a really huge amount, several millions of it, so they would like to store them in a database. Our next part of the presentation will talk about the databases, what kind of databases we support, and what kind of tables you can make in them. And of course, afterwards, we are talking about how you can store these structures in the database, how you can import it, and how they are represented in the database. Okay. Later on, in Tomasz's presentation, we will talk about queries with which you can search these databases, and after that come some manipulations of these searches, some tunings of it, and the visualization of hits. And of course, you can do this searching without database, just given the structures and the queries in memory. Okay, let's see what kind of product family we are talking about. The basis is the JChem base API, which is a Java API, and upon it there are some command line and some easy to use GUI tools as well. Instant JChem is an advanced GUI front-end for JChem-based functionalities. You can have various functions accessing JChem-based tables here. You can create them, also search them, and do many operations to visualize the search results. You have the possibility to use JChem Cartridge. Here you can make SQL queries, and within these SQL queries you can use ChemAxon specified JChem Cartridge operations, for example this GC compare, and through these operations chemical intelligence can be introduced in an otherwise usual SQL queries. Okay, later on I will show more examples with JChem Cartridge queries, but most of the examples will be shown with the Java API. And we also have a front end for Excel and several other products and applications. Okay, so as I told, most of the stuff will be presented with the Java API, and I will show the examples here in this Eclipse integrated development environment, and I will also launch some programs to see their results. Okay, for the cartridge, I will briefly show some SQL queries. Basically, in the cartridge, most of the operations are realized in the workloads where you can introduce, with the help of ChemAxon's cartridge operators, you can make some chemical intelligence. So here you define the column on which you search the following queries, and here you can specify some search options. Okay, so let's jump to the first part, to the database. Okay, there's an easy-to-use graphical program, the JChem Manager. Let's launch it. Okay. Okay, in the JChem Manager, first a connection window pops up in which you can specify the connection parameters. Of course, you can specify the database name, and if you change it, a default template will show up here in the URL of the database, which you only have to change to your specific data. You specify the JDBC driver, the URL of the database, login name and passwords. For this in-memory, for this Derby, not in-memory, for this Derby database, no login and no passwords are set. Okay, so let's see what happens if I change it. Let's change it to another Derby database. Here you can see the template, which you only have to fill, and then you can access your own database. Okay, now I'll launch it again. Okay, now the default parameters are there again. Connected, and we are connected to the database. Let's see how we can do this with the Java API. The main class for this is the connection handler. In the connection handler, you can set the very same parameters that you could set on the JChem Manager GUI. So the database driver, database URL, the property table name, I will talk about the property table, what it is a bit later, login name and password. Okay, some examples for this you can find in the connection YouTube.java examples. Good. Where can you find this? Here among the Java code examples, you click on connection util, there you can find it. For now I will open it in my Eclipse IDE. Let's see what kind of methods do we have here. The get connection handler method just uses the above mentioned constructors and setters. As you can see, set the driver URL, login name, and password. Okay, let's see an example for it. Go to the main. Here, I just set the very same parameters that I set earlier, and here I set the driver, the URL, and the password and login. Connected. After that, I print out the connection handler to see that this connection handler instance was really created and it could connect to the database, and after that, of course, we have to close the connection. Okay, as we could see, it just prints out the very same parameters that specify this given connection. Okay, do we always have to specify these parameters in order to connect? No, we can use other methods. Now I jump back to the presentation. You can store the connection settings. Once you have a connection handler using these properties, you can store the values in these properties, and using the settings handler you can save it. Let's see how it is done here in the connection util class. It's just the very same, provided we have a connection handler filled with the required data, we can store its values like this. Okay, where is it stored? Now I jump to my file browser. We can find it in the user's ChemAxon directory in the .jchem, excuse me, .jchem file. As I open it, of course, we can see the same login password, URL, property table, and JDBC driver names that I specified earlier. Okay, now the values are stored in this JChem file. How can we load them in order to use them again? We can again do it with this settings handler class, and the connection handler can load it from this property specified in this way. Let's go to connection util, get default connection handler. It means that we load them from the .jchem file shown earlier here in this file browser. We load them this way, and of course we handle the exception, and we get the connection handler. Okay, now I will just talk briefly that the JChem Manager, as it launches, as default, it loads the values from this .jchem file, and based on these values, it can fill these fields from time to time upon launching. Okay. Let's see an example here in the connection util that uses these default settings. The connection util has a method, connectDB, which is actually connecting to the database defined by the default connection handler, gets the default connection handler as shown here. Okay, get back, connect the database, connects to it, connects to the database, and returns the connection handler. Let's see it in operation again. Actually, the outcome will be the very same as before, just that in this case we don't specify all these parameters, but load them using connection handlers, connection utils get default connection handler method. We load these values from the .jchem file, print them out again, and close the connection. So as earlier, the connection was established, and here we see the very same connection handler parameters. Okay, now we can connect to database. Let's see how we can proceed further. Of course, we'd like to make tables. Before being able to make them, I will talk briefly about what kind of tables you can use. We provide 5 types of tables, each supporting different kinds of structures. Molecule, reaction, Markush, query, and any structures. Molecule tables can store specific structures, but these specific structures can be complicated as well, so they can contain polymers, and being a mixture of several compounds. They can also contain they can contain these coordinative bonds between metals and organic compounds. but they cannot contain wiring features like query atoms and so on. Reactions, as specified in name, can contain reactions, reactants, who with the help of agents are transformed to the given products. Markush structures contain structures that contain some varying features. Markush structures are used in patents, and they intend to cover as much structures as possible who have the same features. For this, they can provide substitution variations like this R1, on which side this list can occur, where this R2 further expands to this list of structures. It can contain frequency variation, where it's not specified how much from this given atom occurs. A range is specified between which it can occur. It can have a position variation, where bonds attachment is not specified, but a set of atoms is specified to which this other atom connects. Okay, and homology variations which share a common property. Query structures can contain similar variations like in Markush's, but it can further on have restrictive properties as well, like this X3 or R0, which means X3 means it must have 3 connections, although in the query only one's drawn. R0 means that it shouldn't be a member of a ring. Okay, and so on. And any structures can contain all the stuff above, but it's not guaranteed that the specific features are handled. So in Markush tables, it's guaranteed that we can handle these features and find structures that are contained in the library, in the Markush library. If you insert them in any structures, this property is not guaranteed that it can store any kind of structure. Okay, now we know what kind of table types we have. We would like to make them. For making tables, the most important class is structure table options, which contain, as the name implies, options for table creation. As told earlier, we have different table types. So in the structure table options, you have to specify the table type, which is this table type field. You have to specify the name of the table, and you can also specify some other parameters as well if you want to change them from the default, like the fingerprint length and so on. You can also specify a standardization configuration. This standardization configuration is then attached to this table. This means that every structure that gets inserted in this table will be transformed according to this configuration, which can provide you functions with which you can bring structures drawn in different way but meaning the same. For example, benzene in calculi and in aromatic form are brought to the same form, in which way both will be recognized during searching. Examples for using the structure table options can be found in this table operations.java file. And once given the structure table options are ready, you can create the structure table with the update handler's create structure table method. Of course, this requires the earlier mentioned connection handler, which gives you means to access to the database. Let's get to this table options class. Sorry, table operations class. Okay, what kind of functions can we see here? We can see here this create structure table. This deletes the table in order to avoid errors in which we try to create a table that already exists. Creates the structure table options, fills the required fields, and then creates the structure table. Okay, let's see an example for it. We create a molecule table. Let's name it test creation now. Okay. It requires a connection handler, and as noted, as I noted it, you can do it in the earlier shown ways with the connection util, where the connect DB gets the connection handler and also connects to it, and after that, at the end, you've got to close the connection. Okay, now let's launch this program and see what the result of it. So test creation now table should be created. I will show you quickly that it doesn't exist. Okay, this was an earlier table. This is test creation. Now I will make the test creation now table. Now the connection is established and the table is created. Let's have a look at it at the SQL workbench. Yeah, there it is. The table is created. Later on I will talk about the columns in the database when I will show you the import process. Okay, now we can create tables. We know what kind of tables there are. Let's see how you can do it with Cartridge. In case of Cartridge, you can create the same kind of JChem-based table that the JChem Java API can also create. You can create them with Cartridge. But you also have other possibilities as well. Let's assume we have another kind of table, another table that was created by another tool. What required is that this table has a column that contains structures in a JChem recognizable format. Then, for this column, you can create a JChem index with the JChem cartridge. And this index table will contain the additional JChem calculated columns that are normally contained in the JChem table. In case of index creations, they will be contained here in the JChem index. Let's see the syntax for it. Creating a normal JChem table can be done with the create JC table function that requires a name for the table, the JChem properties table. I told you that I will talk later on what this property table means. Fingerprint parameters. If there are further column definitions, that they can be defined here. Standardization configuration. Another parameter for absolute stereo, and these are further options. If you would like to use a regular table which was created by another tool, then you create an index named this. On this regular table, here comes the regular table's name, and within parentheses the name of the column that contains the structures. Okay, here you define the index type, and additional parameters can contain options that regulate the way JChem calculates additional fields. Here the standardization is specified. You can specify here further calculated columns. If we will have time, I will. If we have time, I will talk about calculated columns as well. Okay, now as promised, I will talk about these JChem property tables. In the same database, you can specify different JChem property tables, and upon connecting to the database, you specify to which JChem property table you connect. As default, its name is JChem properties, but you can specify another name as well. And this JChem property table will store options about each of the tables. And once you connect with a JChem, with a given JChem property setting, you can access the tables that belong to that given JChem property table. Once you connect to with the other one settings, you can manipulate the other tables. Let's get back to this SQL Workbench. It also has a JChem properties table. It has property names and values. Let's see what kind of data is stored here. Our latest table was this task creation now. This JChem property table contains various settings about this table, like table type, fingerprint length, and so on. So these are general settings that are valid for the whole table, and the table itself will contain the given structures. Okay, I get another one. This import test already has some structures. Okay, now I close this. Okay, what other tables do we have? Beside the JChem property table, to every table we have an update log table, which is the name of the given table plus underscore UL, which contains information about the modifications on the given table, which is needed during searching later in order to refresh the memory representation of the given table. Okay. For example, this is an update log table for this import test table, which contains information about the changes on this given table. Okay. Yes. Good. We also have some descriptor tables that can contain various data to these tables. For example, Markush screen table contains Markush specific descriptors to every structure in this table. Okay, now comes the other part. We already have a connection. We already have some tables. We created them. We would like to store the structures in this database table. as told earlier, to every table we have a standardization configuration, and upon import the structure is processed by the JChem base, and JChem base feds the structures to standardizer, which will provide the standardized format of the given structures. For example, it aromatizes every structure, or writes nitro and other groups in the user desired format. And then JChem base starts to standardize structures and the original structures as well in the database. Okay. How can we perform this import process using our API? The main class for this is the importer class. For the importer, of course, you have to specify the input file that you would like to import in this table. Of course, we need the structure table and the connection handler. With these three options, you can import the molecules using these functions. You can find methods regarding import in this small import util class, where database import is handled in this database import function. And of course, you need the input file, connection handler, structure table, and with this way you can set up the importer and import the molecules. Here, some other options are also set. For example, during import, you can specify that duplicate must be checked. As default, duplicates are checked depending on the table's setting, but during import you can override the table's settings, forcing the importer to filter the duplicates or forcing the importer to switch off filtering duplicates. Okay, good. And as stated, the predefined standardization configuration that's attached to the given table will be applied on the imported structures. If upon table creation no standardization configuration is specified, as default, ChemAxon's general aromatization will be performed on every structure. Okay, now I can show you a more complex example here in this database import example. This example gets the connection handler, creates the database, and imports structures to this database. Let's see how it works. It has, of course, a main method, which calls the class run method. This method gets the connection handler here at the beginning, creates the molecule table, then before importing molecules, it imports these molecules to the memory. Before importing them to the database, it imports them to memory, and after that it imports them to the database. The creation is done as shown earlier with the table operation class create molecule table method. Importing molecules to the database is achieved through the importer class using the earlier shown setters. Here these three, and after that the import modes will import it. Okay, how do we import molecules to memory? That's achieved here in this list molecules to console. importing molecules to memory, is performed by the mole importer class. Mole importer class requires, of course, the resource, either its string name or a stream. Then with the read method, it can read out the molecules to a molecule object, and after that you can count these molecules and you can write their SMICE format by exporting the molecules with the mole exporter class. Okay, and it reads them until it can read. Good, let's launch this program. So first it creates the table, then it lists the molecules to console, and after that it imports the molecules to the database. Now the listing and the database import, we can see that all the 1,000 structures are imported, and here above it these 1,000 structures are listed, and at the very top we can see that the connection was established. Okay, let's assume we don't want to import molecules from database, but we would like to import them from a given molecule object. That's also feasible. The mole import util gives you means for this. With the update handler, the set structure method gives you means to provide a string representation of the molecule, and the string representation of the molecule can be obtained by the mole exporter. And after that, the update is executed. Okay, of course we got to get this molecule from somewhere, and this molecule import util has also some import functions with which we can import molecule from a string. That's also from with the very same mole importer class, but it's achieved by a static function. The static function will read this string, which is a valid molecule string in some of ChemAxon's supported representation to a molecule object. What is this string now? It's a carbon, a list atom of carbon and nitrogen, and an oxygen. Okay, let's try importing this structure to the database as well. But before this, I will skip listing the molecules to the console because we have already seen it. Let's see how this works. So at the beginning, we create the molecule table just as before and do the database import. Import first these 1,000 structures, and after that we try to import this excuse me, can you hear me clearly? I just got a warning. Okay, I hope you can. So now what happened? Before panicking, just read what happened. We got an exception that inserting a query or Markush structure is not allowed in this table. Oh, okay. Let's get back to the code. So this structure is not, what could it happen? This structure is not a casual molecule because it contains list atom. And okay, thank you. And as a list atom cannot be stored in a molecule table, we cannot import it. And as you could see, if you try to insert an improper structure to a table, you get an exception with this method. Okay, what can be the solution? Okay. Either not importing the structure or changing the structure, or we can change the created table. Let's change it. It has another method, create structure table. It requires the very same connection handler, the name of the structure table, which is the same, and a table type. Where to get this table type? We got the method, table type, constants, dot. Here we can choose which one we choose. Of course, we won't choose molecules because it won't accept them. We may choose query structures because query structures can accept list atoms or any structures. For now, I will choose any structures. Okay, let's see what happens now. Okay. I'm looking. Okay, there it is, the console. We could see that these 1,000 structures are imported, and this latest one with this list atom was also imported without errors. Okay, if you don't believe me, why would you? Let's have a look at this SQL workbench. Data. It contains 1,001 rows, and at the very bottom, we will see okay. So it's also contained in the table as it contains 1,001 rows, but I have to change the number of displayed rows. Okay, reload it, and there it is, our list atom. Good. Let's jump back to the presentation. Okay, now let's see what kind of structure, what kind of table columns we have. The imported structure is stored in the CD structure column. Let's have a look at it in the SQL workbench. So the imported structure is here in this CD structure column. You can see it right here. Show as text. It's this one. This is the original format. Okay. This imported structure is then standardized, in which case the standardized structure is stored in CDSmart, CDSmart, so CD Markush columns. These depend on what kind of table type we are handling. Okay. You can find it here. It's in the CDSmart column. Okay. And based on The standardized structure, the CD formula, CD sortable formula, CD mole weight is calculated. These contain various features. You can find them here. CD formula, sortable formula, and mole weight. Okay. And based on the standardized structures, we also calculate the CD hash, CD flex, and CD fingerprint. Hash, fingerprint are used for screening before searching, and CD flex contain various data about how the structure is represented in the CD SMICE field. You can find them here. This is the CD fingerprint, and this is the CD hash. From fingerprint, we have several columns, as there are, as default, 512 bits. Okay. Now, structure caching and fingerprint will be rather covered in the searching part if we don't have time. Before that, I will show some other aspects of table creation. During table creation, you can specify additional columns in JChem Manager, for example, and these additional columns can contain various features. Here you can use ChemAxon's chemical terms expressions to calculate various features like log P, rotatable bond count, and pKa. Let's see how it's done in JChem Manager. Sorry. I have to close the workbench, otherwise I can't connect to it with another tool. Okay. Now JChem Manager opened. Either upon creation I can specify these columns, okay, or later on I can click the modify icon and opening this test, I can add columns, further columns. Here, for example, I type log P. Its type, let's say it should be numeric. And here I can write the JChem recognized chemical terms expression. This field specifies the type, and this field specifies how this additional column is calculated. Okay. I have a further one. Let's see, pKa, also numeric. Acidic. Okay, good. And by clicking done, these columns will be generated to this test class, to this test table. Okay. You can do the same with our Java API as well. And examples for this you can find in the calculated column search example. I won't deal with the search part because that's Tamás' job, but here I deal with the creation. First, of course, we drop the structure, and the main point, main difference to a casual table creation is the retrieval structure table options. beside the so far mentioned columns, we have some other columns, other fields of table options. Here, these ones. In extra column definitions, we can provide the names and the types of these new columns. Here, 3 additional columns are defined, and later on we can specify a hash map which contains the name of these fields and a chemical terms that specify how this given column should be calculated. And once these options are specified, once these fields are specified, we can create the table in the usual way with the structure table options. Okay. Let's see how this runs. So here is this create table, and after that the database import is called. And let's see, it's run. It again protests because we have another connection. Now the connection could be established. It sets up the table. Soon it will finish the import. As it finished, we look at the table with the SQL workbench, and I will show you the generated pKa and log P fields. It's this demo. Okay. Here we can find that additional 3 columns to the so far seen have appeared. Now let's see the data. So the usual columns come here, and at the very end we can see the further 3 columns here: log P, rotatable bond count, and pKa acidic. Okay, and just one very last memo. You can do the same with Cartridge as well, with the create JCT table function, where among the options you can specify chemical terms configurations, where the log P, rotatable bond count are specified as shown before with these chemical terms expressions. Okay, thank you for your attention. I have a look whether we have some questions.
Yes, thank you, Robbie. And if you have questions, then use the questions panel on your right, and we're gonna answer them. At least we try. There is a question. I don't know whether you can see it, Robbie, but it's about the performance that we use in MySQL. And big inset pumps about 200 structures per minute. Is that, sorry, 200 structures per second. Is that similar for IJC or JChem directly?
I think that was measured on JChem, but IGC can provide the same speed. Excuse me, what speed is this? Is this for import or searching?
It's for import.
I think it's for importing. I think IGC can provide the same speed as it uses our API, and the graphical user interface won't mean an overhead to slow down this process.
Okay. There's another question. It goes like, if I want to create a JChem table in Java and I don't have property table in the database, how can I do that?
You can do it with API as well. Sorry. You can do it with API or by launching JChem Manager. If you launch JChem Manager and you just write a new JChem property table, it will create it. With the API, you can do it with the database property class. Database properties dot create property table. Yes, with this method you can create it, where the connection handler will specify the property table name. You can also read the API documentation of database properties class.
Okay, there is other question. Is there any way to set time limit for structure generation from smiles using the API?
Actually, this question is oh, okay. So this question doesn't belong to the database team. It belongs to the IO team. I don't know such a time limit, but it's better to ask the experts for this. But maybe we have someone from that team as well. Yes, and an expert from that team also responded that there is no mean for setting time limit for importing from a string. Import with duplicate searching. As I told, sorry, is it? You can set. Where was it? Database import. On the importer, you can set if duplicate searching is allowed or not. Set duplicate import allowed with the int value. If you don't set this, then it's then it will be specified based on the tables option. Otherwise, it can be overridden here with this